killer planets, crazy stars, monstrous explosions, and terrifying black holes. Let's go!
Mission liftoff.
Hello and welcome to another episode of Dr. Gibberish. Today we'll look at 8, in my opinion, most dangerous places in space you may want to avoid with that fancy starship of yours. And we'll start with Tres 2b. This exoplanet in Draco constellation, 750 light years away from Earth, is the darkest planet we know of. It reflects less than 1% of any light that hits it, meaning its surface, if there is any, is covered in absolute darkness. Also, because the planet orbits its star in a rather tight orbit, Tres 2b's average temperature is a whopping 1373 kelvins, or if you wish 1100 degrees Celsius. If hell existed, that's precisely what it would look like. Dark, scorching and scary. Next up we got HD 189773b. A hot Jupiter-style planet looking as beautiful as it sounds. Located only 65 years away, at the first glance looks just like our Earth. But thinking you can safely land your spaceship there would be a grave mistake. HD 189773b has arguably the worst weather in the universe because it constantly rains glass. To make it even worse, the winds blow with speed up to 8,700 kilometers per hour or 5,400 miles per hour, sending the microscopic glass shards around the planet faster than ISS orbits the Earth. Anyone unlucky enough to find themselves stranded in this world would be instantly ground to little pieces before they even manage to cook alive in immense temperatures reaching 1100 Kelvin or 873 degrees Celsius. Next on our list is a neutron star. Incredibly dense object born from collapsed cores of dying giant stars. Calculations imply that neutron stars are almost entirely made of, spoiler alert, neutrons. After a giant star dies, there is no more thermonuclear reactions inside of it to balance the gravity pushing down on itself. So the core collapses under its own gravity, squeezing atoms of matter with this incredible force, losing their negative and positive charges and melting into this weird, super dense neutron soup. How dense? These weird stars are rarely bigger than 15 kilometers in diameter, smaller than New York City, but comparable to mass of our own sun in its full glory. You surely know how easy it is to lift a spoonful of sugar, but a spoonful of neutron star matter here on Earth would weigh almost 10 billion tons, as much as an average mountain. Not mentioning being so close to such a massive tiny object would rip you apart instantly in a very spectacular way. What's more interesting, there is more than just one kind of a neutron star. Some neutron stars become very rare objects known as the magnetars. Neutron stars with incredibly strong magnetic field, millions of times stronger than that of Earth's, and around 100 million times stronger than any magnet ever made by humans. If we were unlucky enough to have a random magnetar appear halfway between Earth and the Moon, the magnetism would be strong enough to wipe clean all information on all credit cards all around the world. And it would probably also wipe out all the life on Earth with its insane radiation. Magnetic field of Magnetar is so strong it can cause what's known as a starquake. A horrifying event where surface of the star cracks and releases gamma ray flares, powerful beams of radiation that can travel incredible distances. If Earth was unlucky enough to find itself in path of such a flare, it would sterilize the planet of all life. Luckily for us, the closest magnetar we've observed is 9,000 light years away in Carina constellation. Our solar system is sort of located in the suburbs of the Milky Way, far away from such dangerous monsters. Quite scary and cool, isn't it? Now, how could we possibly ramp it up? Just like you make everything more cool and dangerous, you make it spin like crazy. Ladies and gentlemen, the craziest and, if observed from a safe distance, the most beautiful form of a neutron star. A pulsar. Which, by the way, you might remember from the previous episode about exoplanets, which if you haven't seen, you might want to check out. These degenerate stars rotate at bizarre speeds, emitting powerful beams of electromagnetic radiation, including visible light, from its magnetic poles, kind of like a deadly radioactive space lighthouse, blinking in the sky in regular periods. Although you don't have to worry too much about its radiation, because the closest pulsar we've ever observed is 280 light years away from Earth, way too far to do any damage. Very interesting form of pulsar, subspecies you might say, is a millisecond pulsar, or MSP for short. These bizarre monsters spin incredibly fast at almost 70,000 km per hour, which is almost 24% of speed of light. To understand it better, listen to this audiograph of pulsar's radiation received by radio telescopes here on Earth. Every click means the pulsar has rotated by 180 degrees, which, if you remember, takes Earth 12 hours to complete. So, here is a standard issue pulsar. Here's a little faster one. And this is a millisecond pulsar. Speed! Yes! But sometimes dying giant star's core collapses even further down on itself, compressing matter so densely that it's packed almost in a single point known as the singularity. A heart of a black hole composed of degenerated star matter compressed beyond human understanding. Nobody has ever seen a singularity, and nobody ever will. It's hidden behind the cloak of event horizon, a distance from a black hole at which nothing, even light, can escape its immense gravity. At this altitude above singularity, it's physically impossible to maintain a stable orbit, and even light is forced to fall to the surface of the black hole's core, so it appears as a hole, a circle of nothingness, pitch black darkness. As all light that falls on it remains stuck to its surface, so no light can be reflected back to our eyes. This bizarre object's gravitational field is so strong it can stretch matter and even time. But more about that in a separate episode dedicated exclusively to these mysterious monstrosities. Next on our list is a hypernova. Similar to supernova, a massive explosion ending a life of a giant star, but with much greater kinetic energy and thus packed with much bigger boom, resulting in a stellar explosion over 10 times stronger than a regular supernova. Hypernovas happen when a massive giant star at the end of its life cycle collapses straight into a black hole. These rare cosmic events are one of the mechanisms for producing long gamma ray bursts, which range from 2 seconds to over a minute in duration. If Earth was anywhere close enough to such event, or happened to cross path with a gamma ray burst, all life on Earth would perish within a fraction of a second. Last time we observed a hypernova was about 170 years ago, when one of the brightest and most massive stars in the Milky Way galaxy, Eta Carinae, collapsed and its outer layers exploded away in an incredible explosion, created what we can observe today as the Carinae Nebula. Last on our list is an absolute unit, the OG star killer, the biggest gangster in the hood. Quasar. Quasars are supermassive black holes with mass ranging from millions to billions of times the mass of our Sun, surrounded by a gaseous accretion disk created by stellar dust and objects that were unfortunate enough to come too close and were ripped apart. As gas and matter in the disk falls towards the black hole, energy is released in form of electromagnetic radiation. The power radiated by quasars is enormous. The most powerful quasars have luminosity, the scale of how bright they are, thousands of times greater than a galaxy such as the Milky Way. Radiation from quasars can be seen in form of jets, which can be as long as 1 million light years. For comparison, that's 10 times the length of our entire Milky Way galaxy. If we had one within a couple thousand light years away from us, it would be able to completely annihilate all life on Earth. Luckily, these monsters, also known as active galaxies, can be found only in the oldest parts of the universe, far, far away from Earth. So far, in fact, their light took on average 10 billion years to reach us. And that's it in today's episode of Dr. Gibberish. If you haven't done that yet, please consider subscribing to the channel, as it really helps my videos to reach to more and more people. If you have any comments, questions or corrections, please don't hesitate to leave them in comments below. If you enjoy my videos, please consider showing Dr. Gibberish to your friends and family. Who knows, maybe they will get interested in science and space just like you and I. Also, please make sure to follow our Facebook page, where I post cool facts and juicy memes couple times a day, every day. Stay scientific, my friends, and see you next time.